Hi, hello everyone. Today I'm going to let you know about my final project in deep learning with big data. My name is Ganesh Pasiganti and I'm going to tell you all about my deep learning with big data final project. First, let me tell you about the deep learning part that we have. Deep learning, which has emerged as an effective tool for analyzing big data, uses complex organisms and artificial neural networks to train machines, computers, so that they can learn from experience, classify, and recognize data images just like human brain does. With the deep learning in convolutional neural network or a CNN is a type of artificial neural network which is widely used for image object recognition and classification. Deep learning thus recognizes objects in the image by using CNN. CNN are playing a major role in diverse tasks like images, processing problems, computer vision tasks like localizing and segmentation, to recognize obstacle in self-driving cars as well as speech recognition in natural language processes. So this is a brief introduction about the deep learning process that we have and that is currently going through. Let me go to the next slide. As we all know, this subject is all about convolutional neural networks and how the way it works for the image classification. We all know that it's totally good. And better neural networks when compared to artificial neural networks for the image classification. So I would like to present my basic example of convolutional neural network where I have used an image in the process of convolutional neural network before going to my final project explanation part. So coming to that one, yes, here a simple example where I took a koala sleeping picture on the tree, on the branch of the tree, where to summarize things, I just skipped one picture and I will explain deeply in the next slide as well as, yeah. So here you can see a convolutional neural network is of two phases. One is the first phase is a feature abstraction and the second phase classification. Where the first feature extraction, convolution layer and the radio in the activation layer and cooling the pulling comes and cooling the pulling layer comes under feature extraction part. When we want to include more layers, we will include more layers for better enhancement of for the better image. So that's all about the feature extraction part in summarizing. And when we come to the second part, which is a classification, where it have fully condensed connector layer, the output where we can tell is a cola or not. Coming to this, where we perform analysis for the picture to find out whether it is a cola picture or not. In here, we first analyze, we calculate separate for all the parts of the cola with performing feature extraction for all the parts where we can see for the eyes, nose, ears, hands, and legs. In here, we perform convolution operation where with the part of eyes as in the green color. One bite, guys, one or over here for the ears and hand legs are as well. One moment, let me take away this the watermark that we have present. One moment, please. Yeah. Yeah. So the ears and the hands and the legs as well. So these are the filters in the filter size and strands, and these are called max pulling layers, where we pull all the filters when we have to do because these are the images or something, one single color with this full part of full patch. So we get many filters by using cooling layer with the maximum pulling. With the maximum pulling, then we will combine all these filters and we will get maximize the pulling layer and then we flatten the matrix. Yes, then we will get the output, whether the picture it is called us or not. When we come here to the second part. As you can see, the picture is different, but is also a cola in sleeping position. When you can see it from the different on the first picture and the second picture, the eyes, ears, and hands are so, I mean, the part of the collar will be same with the different bits, whether it is a different picture or the same picture, right? So when you see the filter size, when you all see the filter position of eyes on the eyes, nose, ears, and legs, and hands are being changed because the position of the koala is not seen in the first picture and the second picture. The first requires sitting in the second picture called as sleeping right. So they get different, very different. As you can see in the first picture, the outputs are little different from the second picture, and after combining, those will get the flattened Mac flattened. In the fully tensed network, the position would be different. Here, in this, you can see in the third one, the last but one, two. As you see in the second one, second picture from koala sleeping. It's on the fifth, same comes with the from the down part, from the download as well. It's on the third. So when you see this is the first layer, I mean, this is the first phase where you have to perform conversion operation. This is the image which we have taken. Yes, we use conversion operation, pulling layers, and activation function, and the flatten, and the combining to next part. This is called fully dense connected layer. As I repeat, this is called fully dense connected layer, where this is dissolved. This phase is called classification base of the conversion network. Let's go to the next slide. Yeah. So here comes the part one. As I mentioned in my index, it has around five parts and with a conclusion. So here starts with the first part. Yeah. So this slide is totally based on Russian audio visual database of emotional speech and song raptures. Speech audio only files. I mean, I took only speech audio files because I think they are enough. Yes, we have taken only audios or the image files. Audio or image. So why I've chosen audio? Because it's a little interesting for me. I have never seen or listed down the audio datasets or audio files before this. I'm getting to know that there will be audio data files as well as doing the final process. So I have researched thing and I have listened to some of the samples in this database and which are very interesting. And yes, I have obtained this wrap from the dataset from the website that has been mentioned in the document. This contains some audio files and the port. Yeah, this portion of the wrap disk files contains, as I told, speech audio files. So these are 1040 files which contains or 1440. I exactly don't remember the number, but which contains 60 trials per actor. There are 1440. Yeah, I'm sorry, 1440 are the trials and 60 trials per actor. There are 24 actors. That's why it is one line that contains 24 professional actors where 12 are male, 1 are female, 12 are female and 12 are male. And they are localizing the two lexically matched statements in neural North American accent. So in this, speech emotion include calm, happy, sad, angry, fearful, surprised, and disgust expression. Each expression is produced at least two levels of emotionally intense, normal, and strong with an additional neuron expression, as you can see down in the picture. Surprise, fear, happiness, anger, and all the pictures you can mean, and the basic example of rap test. Coming to filling the file naming convention, each 41440 files have a unique file name consists of 7-part numerical identifiers and find them identifiers as well as we have local channels, emotional intensity statement, and repetition, and actors these are identifying the emotions. I mean, defined as neural due to the calm tree of 4% is equal to 6. It's called fearful, and somebody's gonna discussing this whole software as you can see in the picture in the slide. I'm sorry, maybe I bit make you confused, but yeah, this is what I actually mean. Yeah. So when come to the statements, keeps it talking about the do jobs and setting up the do. When you come to the repetition, 0, 1 is repeating one time, 2 is for repeating twice. Yes. I told you there are 24 actors, 12 male and 12 female are odd numbers and even numbers of male. Yes, this is the final example for that. All the information which I have given before have been provided here as well. I might not changed the slides maybe, but it's all the same. One moment. Yes. All the information that I have given you before, you can find a similar kind of information in this chat as well. Like the file identifiers and the convention model, the file naming convention, where it has 144 files with a unique name, it has 7-part numerical identifiers. The file, when it comes to the file name identifiers, you have different set of it, like modality, vocal channel, emotions, intensity, statement, repetition, and actors. As I said, there are 12 male, 12 female, 1 to 24 as the old count. Odd numbers are male, and even numbers are female. Next, go to the next slide. Uh, yeah, here we have the file example. Yes. So, as I told, I'm working on the iOS part. I only opted the audio files, speech, the fearful one. These are just a basic observation which includes all the variables which I have shown in the first slide. Yes, this is one we all know what is this is right. So in this you can see a different I have taken example of the well-known actors where you have like all the emotions have been capturized on the right side of you, where it shows you surprise, neutral, and anger part, and the other actor shows the joy, neutral, surprise, and the sadness. So this tell you the basic example, like how the audio files or the files that I have taken have been chosen from. Uh, let's go to the next slide. Yeah. So here comes the part two. Yeah. How we can, the part two is all about how we can obtain the CFAR10 dataset and transfer all the data, all the files of those dataset to the remote virtual machine. So let's start the process. I have included all the points on a high level basis or in a brief note, like how I have done this the data files transmission to the remote virtual machine. Yeah. So opening the CFAR dataset and transferring all the data files to of the device to the remote machine. This is very important thing which we need to do prior to performing building testing training for our CNN model. In here, I have just uploaded all the required data files which I have provided in the canvas purpose. In the next part, I just wrote clearly just some steps. Just download the files from the canvas, transfer all the files of the data, remove virtual machine by accessing remote virtual machine in the GCP. All the commands, give all the commands, create the Jupyter, upload all the files in the CFAR dataset from the local to the newly subfolder, the removing standards at the part 3. You can see the applying commands, the build, train, and test in the part 3. Yes. Here, as I mentioned, uh, like the subfolder I have created is jp underscore ntbt in the remote virtual machine. And after creating that subfolder, it is named as CFAR10 dataset. Uploading these files into the local machine newly created subfolder in the remote instance. Let's go to the next slide. Yeah, slide 9. Yes. So here we work on the surfactant dataset where we have to build, train, and text convolutional network. Convolutional neural network on the CFAR dataset that we have chosen for. After uploading the files from the part 2, now we are set to start this part. Now we set the path, then we start process of building, training, and testing on the CFAR dataset. First, setting up the path, then loading the data and displaying some images using the matplot library. Then we have to give some supporting functions to rearrange the data, like one hot encoding, setting up images, which will feed into the first conventional layer. Then we give the function which will be helpful to build, train, and test in CNN model. And then performing conventional computation, which is a dot product. These are the supporting functions which we have used for before declaring our first conventional layer. We have initialized weights. where this variable, this function returns user to store weights in a filter. This variable is initialized with the values that can be used to infiltrate weights. And we have used the function bias, which is initialized to 0.1. And we have used the conventional and performed conventional computation dot product. So now you can see we have defined the function, which is conventional 2D inputs, which batch height, weight, and channel output, and also inputs. Yes, we have to declare output and input. Yes. We have created a conventional layer and a computation dot product with the filter with the initialized width. Then let's go to the further process. Let me stop this for and keep this as a part one.